just finished putting on my gloves properly. Today we're looking at ticket number 13161, and it's a faulty PlayStation 4 that has faulty USB ports. So 2 USB ports at the front of the PlayStation 4, just about here, if I can hide my face so it autofocuses. Now, they were filled with a lot of stuff, and the PS4 itself was without a doubt very dusty and had a lot of hair clogging up, etc, etc. It looks like maybe some pet hair. I'll leave some photos on the screen. Now, ignore the Crocs. After giving them a good clean out, they still weren't working. I put the motherboard back into the PlayStation 4 and just give it another test. And when I say I'm not working, I plugged the PS4 controller in with a micro USB cable, and it's just not syncing or charging the controller. So we have no data and we have no power. If we head on over to the microscope, after doing a bit of research, this chip here is responsible for said USB ports. Now, I haven't done any diagnosing yet. I've literally just stabbed myself with the prongs on the multimeter. I've not done any testing as of yet. I just thought I'm going to hit record and see what the situation is under the lights. I've got my multimeter in continuity mode, and just to check on some things, we've got a couple of caps, and I just want to see if maybe any of those are shorted en route to the chip. So this side here is meant to be ground, I'm going to assume, which makes sense. So we don't have a short there. That one, oh, so this one actually goes into the IC this side, and this side is ground. So maybe either this chip is faulty, as confirmed by our suspicions and our research, or this cap is actually faulty. I will just go ahead and check any other components. Now, the reason I'm checking other components is purely because if we have another short on another cap, it's most likely going to be the chip. But we have the resistors all around as well. Okay, so I've measured all caps. There aren't any more components around this area. I think quickest solution here is actually going to be to remove this little capacitor here, or at least just move it over. If we don't have a short on this path that we have here, then I can measure the cap off the circuit to see if we actually have a short, because at the moment we're going to get continuity through the cap. Let's take it off the board, or just move over a bit. I've not actually personally come across this fault before with the PS4 USBs not working, so it's a pretty interesting one, and I like it when I haven't worked on something before because it's exciting. So we'll just move this cap over. I'll tell you what I am going to do as well, is give this a tiny bit of flux, just a dab, and we'll come in with our fine tweezers. I'm just going to try and move it onto the left pad. I was looking online, and these chips are not cheap. You're looking somewhere in the region between 20 and 40 pounds just for this IC above this cap, which is crazy considering how old the PS4 is now. It's nuts. Okay, the cap is loose. Just move it over there, wait for it to solidify. Sweet. All right, now we put our probe. Actually, let's do it this way. Let's test this cap. We don't have a continuous path, so my guess is that this is shorted. Wait a minute, it's not. Oh, wait a minute. Meter's still figuring it out. Maybe it's a little bit hot. Yes, we still do have a short. Okay, so again, just to confirm, no, that's fine. Now that the board's a bit cooler, yeah, we still have a short. All right, so this IC needs to come off. Before doing that, again, that's a random guess in the dark. So I have a donor here, and I'm just going to see if that behavior that I've diagnosed isn't normal. So this is a donor board. So if I put the probe here, yeah, we don't have a short here. So that side is ground. This side goes directly into chip. And yeah, we don't have a short. Perfect. Right, let's replace that IC then. Hopefully, that fixes it. I'm going to apply some flux around it. So I'll tell you what I am going to do, actually, before we continue. There's quite a lot of dust. So I'm just going to give it a quick clean. Are these tweezers big enough? Yeah, they are. Look at that. Lovely. Okay. Play some flux around the IC. Just around the edges. And we should start to see that solder come away, hopefully. Okay, on the left side is good. Just waiting for that top side, I think. Can have a big ground underneath as well. So I'd say this is probably about the size of the PS5 retimer IC, the HDMI encoder. We're not trying to force it off in any way, shape, or form. Just taking it easy, patience, and it will come off. There we go. Nice. Whilst I'm here, I'm just quickly going to clean some of the flux whilst the board is hot, because although flux is our friend and we love flux, we don't need way too much of it to drown the board, you know. So we just clean as we go. There we go. I'm just going to prep the pads here, so a little bit more flux, fresh flux that is. Use our thin tip here and just go over these pads. Now what I'm doing here is mixing it with leaded solder, so it reduces the melting temperature. What that means is that it should be a little bit easier for us to put the IC on. And if it ever needs to come off in the future, it can do. There's a little bit of solder in the middle as well. I'm just going to apply a tad more flux, just to ensure we don't have any bridges when we put the IC on. A few bridges are okay, but we don't want anything catastrophic. So, yeah, we look okay now. Quick removal of that flux. We'll apply some fresh in a second. Now we're going to place our chip onto the board. We've I put a fresh little bit of flux just there. Move some of this flux around so that we're looking a-okay. And as soon as we start to see the solder molten, I'm going to gently come over the chip and see if we can get this on with no issues, hopefully. So you can see the solder there starting to wet. It's perfect. Coming with the IC. And hopefully in a second. It's just a little bit up in this corner. And that's most probably going to be because of the ground on the IC itself. So I'm just going to give it a little tap. And it's still up, I would definitely say. In the corner. There we go. You have to make sure that the chip is centered. Which, to be honest with you, I think we're okay. Looks pretty centered to me. Might need to come down a tiny bit at the top. There we go. That's better. I'm going to come off the heat. Again, come in with some more flux. Now we're just going to push down on the IC to ensure that we have a contact. A good contact, that is. Which it looks like we have there. Again, come off the heat. Now, the only other thing that I need to do is put that cap back. So I'm going to apply some heat down here. Take a little cappy. Put a little cappy back. Tiny bit of fresh flux. And just reflow him into place. There we go. Send him back home. Lovely jubbly. And now, you guessed it, a clean. And a check to ensure we're all good. Not applying any IPA at this point. Now, it's our final thing. I know I've just cleaned and now I'm adding flux. A little bit of solder on the end of our tip. And just all the way around the IC. Now with these chips specifically, or these type of chips, sometimes it's not going to look soldered, but what you'll find is that underneath there is a connection. There we go. Right. Another quick clean. And we can inspect. How are we looking here? Looks okay from that angle. I can't really see any bridges or anything, which is nice. I guess the key thing we're looking for here is bridges. That looks fine. Again, if we're not seeing full solder connections, that also looks fine that side. Then I'm not too worried because I reckon and believe that it will be connected underneath. And final side. Yeah, nice. Okay. I guess then, do we have a short on this cap? Yes, we do. We still have a short. And I didn't test if we had a short or not when I removed this chip, which is probably a rookie mistake. This is directly the other side of the board. And it looks pretty messy. I don't know what this is here. Whether that's meant to be there or not. Oh, that might be flux that's gone through the wires, potentially. Maybe flux that come through the wires. But yeah, this is the other side. I just wanted to check and see if potentially then it was one of these caps instead of the chip, which would be funny. Not massively funny because time is money and whatnot, but a good video nonetheless. Let's have a look and see what cap. I bet it's this one here, isn't it? No, it's not. Is it this one? No, it's not. All of these are shorted. Wait, oh no, that's ground. Oh no, these are all shorted. Most of them are. That's shorted. Obviously that's shorted because it's on the same path. This side I'm going to assume is ground. That's shorted. That's shorted. That's shorted. That's shorted. Okay, so maybe... Wait a minute then. I'm going to have to inject voltage here because I don't know if it is the IC or not. It might be something else. The IC that we've just put on, I highly doubt... Well, it wasn't showing shorted, was it, on the other board? So I'm going to have to inject voltage here and see what's going on. We're going to start with a measly 0.5 volts. And I'm going to see if anything gets hot. Okay, here we go. What kind of draw do we get? I'm going to use these big caps here. We get an amp. That's me jumping to conclusions. Still, every day we learn. I've got the big lens on at the moment so I can see a wide area. Where is that? That's up here. Oh, it's this circuit here. Wait, what? Okay, let's put the smaller lens on. And to prove it, what an interesting fault. Ah, can you guess? Let's put the lights back on. Can you guess what cap is faulty? For the sake of science, where is the IPA? We're going to inject it at the same place. And reveal yourself. Do you know what? I don't actually know. Maybe I've assumed wrong. I thought it was the cap that, obviously, looks a little bit discoloured here. I thought it was this one. But I don't know now. Now we're a little bit closer. Let me try again. Bit of IPA on the top. Maybe I was just a bit slow to observe. Yeah, I think it is sizzling on top of that cap, you know. Bit more. I think it is. Right, I'm going to remove that cap. Trying to locate exactly which one it is. It will take me 2 seconds to take it off. Might be the one on top of it, though. Just to confirm, actually, with our multimeter. This is shorted, yeah? Yeah, so this cap is shorted. Okay. This cap's taking a lot of heat. I think it is maybe fused to the board a little bit. Okay, how are we looking? Are we looking shorted, Mr. Cap? Yeah, we are. So that cap is completely shorted and now disappeared. So we turn the board over. Originally, this little cap here was shorted. So, and this is next to the IC that we replaced. I'm going to check here and make sure short be gone. It's not. We have a 7 ohm short now. So this was a dead short to ground before. It's now 7 ohms. What? So do we still have a 7 ohm short here, which is where I've been injecting voltage? On here? Yeah, 7 ohms. What? That's so strange. All along here, as well as here, exactly the same. Exactly the same. What's next then? I'm just going to double check the actual USB ports and make sure that there is nothing in them that might be causing this short. You see, they look fine. The pins are all okay. Oh, wait a minute. Is there like liquid damage there? I mean, they are rusty, right? Look at that. They need to come out. There's hair and all sorts at the back of them as well. I think they do need to come out. Don't know if that's actually going to be causing our short, but it's definitely not going to be helping the situation. Let's get these USB ports actually off. All right, so that took a little bit longer than expected. However, we have a nice, clean couple of USB holes, I guess, is the terminology. If we go back to the place where we had the shorts, and remember I moved this cap here, I took it off. Do we still have a short, or is it gone after we've removed the USB ports? No, it's still there. 17 ohms. So it's 17 ohms, which still goes up to this cap, I'm assuming. Yeah. So we still have a short there. And like I said, I can't inject voltage. If I inject voltage here, 17 ohms is too much of a high resistance to inject anything. I don't want that traveling all the way into the APU and then busting the APU, which this thermal paste is very questionable. That was from a previous repair job. So I think one of the only things that I can do now is take off this chip and see if we still have the short. I have no doubt in my mind that that is where the short has come from, is all of this corrosion and stuff that we have on the ports themselves. You can see they're in really bad condition. Now it's leaded solder, and we've already done this chip once, so it should come off fairly easily. But we're still going to add some flux, just to ensure that we don't have any rip pads or anything like that. Again, nice clean pull. Okay, do we have a short on this cap here still, which is where our short originated from? No, no short. Okay, so we don't have a short there, but now it's not having a chance to connect, I'm assuming, to the back bits here. So let's see if we have a short here. Okay, no short here. So our short is gone when we took the chip off. What about here? Yeah, okay. So all of these caps, again, we don't have a short now. I am just going to check every single cap. No, okay. Don't have any shorts there. I'm going to get another chip then. All right, new chip installed. We look good from a soldering perspective. So let's see if we have a short on this cap. And if we do, it's not going to be the chip. And I don't actually know what to do next, if I'm being 100% honest. Okay, here we go. Okay, so we're reading about 140 ohms at the moment. The board is still relatively hot, so I'm going to give it a chance to cool down. Oh, that's solder squeezage from the other side of the board. Nice. So short-wise, down here, 235 ohms and still climbing. Still a little bit warm, I guess. I'm going to check in diode mode and see what we get. 0.157. Okay. And what about up here? because this is all connected, I'm assuming. 0.170. So it's climbing. 0.2, 380. All right, so quote unquote maybe normal then. Maybe we have sorted out our short, which is obviously good news. Let me just double check here again. 168. Okay. Just to solidify my findings, this is again a donor. I'm going to see what diode reading we get here. That's 0.248. So I'll check in these areas as well. Yeah, 250. 250. I'm saying that this donor board doesn't have a cap here, so I'm going to do some digging and then I'll confirm something in a second. I can't actually find too different on any of the other donor boards I have. However, this board is a 1-1 and the only other boards I have are a 2-1. I don't know if that's going to be enough to make a difference, but again, on here, I now get 0.192. And it's stable. I think what I'm going to do is put the ports on and see what happens. All right, so the new USB ports have been soldered in. As you can see, all of the solder joints are lovely and solid. There is a little bit of solder here though. What are you doing? Get off. So yeah, everything seems to be soldered as it should be. So wish me luck and let's see how this goes. Here we have the PlayStation. It is assembled. I need to give it all a nice clean, but there's no point in doing that until I know if it works or not. So does it power on is the first question. Yes, it does. Do we get a white light? What was happening before? I have the PlayStation controller here, the test controller. When I was plugging in the cable to either of the USB ports, I would get nothing on the controller at all. No charging light, nothing. Still sat on a blue light at the moment. There we go, white light eventually. So now we go ahead and I'm really nervous actually. Plug that in. Do we get anything? Any power? We do, yes, we get charging. It's just turned off. Maybe the controller's fully charged. Push the button. Yes, it syncs. There we go. I'm going to just quickly play as guest. I don't want to give any profiles away or anything. But the controller's working. So I've just properly disconnected the DualShock controller. Unplugged it. And it's in the second USB. I'm just plugging it into the controller now. We get nothing with that one. Let me try again. It doesn't feel loose or anything. Shows is connected. I don't know if that's because it remembers a controller. Let me just try again. I've turned it off. So I plugged it in. Nothing. Try the first one again, just to make sure it's not coincidence. Yeah, first one's fine. It's now the second one we have an issue with. Okay, so let's investigate that. So I've been on quite the wild goose chase. The port that is quote unquote faulty is this one over here. And I was just measuring in diode mode to see if there was any differences between this port and the one over here, which there was. And the difference was this pin right here. So on this side, I get 0.459 in diode mode and 0.459 here. If I go over, I don't know if they are paired. They might not be. I put my probe here for diode mode. That's 352. And this one is 487. So there's a clear difference here between that pin and the other pin on the other port. There's no lines to show where these go. So I then flip the board over and I can see this filter here and this pad here. Now, if they are joined together, I'm going to go ahead and assume that it's this filter here that is responsible for those connections or passing through the connections. And we have the exact same one on the other port. And I thought, I'm just going to double check my theory. So I measured here and I get 0.486. I measure here. I get 0.35. So it's different. Now I thought we could either have a problem with this filter or we can see where it goes. I follow this trace all the way down and it goes to these vias here. I turn the board over and look where those vias go to. And would you look at that, they are here. And where does it go? Into the chip we replaced. Now, if you can spot the mistake, amazing. If not, I'm going to zoom in. I believe specifically it's this via here. We follow it around. Oh, what's going on here? That does indeed look like we have a small bridge on the IC. Lo and behold, if I measure here, we have 0.35 and on here 0.35. So what we do is apply a tiny bit of flux. What do we measure now? Is it still connected? No, I get 0.461 now. And on here, the 351. 461. Nice. One last clean. There we go. That looks better. Bridge be gone. Subsequently, if I now measure on this joint here, yep, 463 and 456. So maybe they're not paired, but clearly they both go to that chip, so we should be okay. Let's give it another test. Okay, testing. Port number 1. Nice. Testing. Moment of truth. Port number 2. Yes, let's go. Okay, sweet. That seems to be working. All that's left for me to do now is give this a really good clean. But we can consider that fixed. We went absolutely around the houses with that one, but it was a really interesting fix. Hopefully we're going to have a happy customer whose PlayStation 4 will now live for a little bit longer at least. Thank you so much for watching. I'll leave a link to another repair up here, and I'll see you in the next one. Peace.